Alright, C. Lindelof videos. We're asked here to find the vertical asymptote of our function. This is a really interesting function because this function has two types of discontinuity. There are more than two types of discontinuity technically, but the two that are most prevalent, the ones that we talk about most in AP Calculus, are holes and vertical asymptotes. Here we're asked to find a vertical asymptote. The way that you would have to do this, though, is this. Well, let's just look at this for a second. If we factor out the bottom of this function, we would get x minus 2 times x plus 3, right? Now what I'm going to do just for a second is I'm going to put this other function back over it, but I'm not going to factor it yet. So if you look at this for a second, it might seem to you that we had vertical asymptotes at x is equal to 2 or x is equal to negative 3. That would be true because the function would become undefined there. So we say, okay, if the function is undefined, we have a discontinuity. And the question is, what type of discontinuity do we have? So what you have to do further from here is this. What I'm going to do here is I'm going to factor this top function out. And I think I get x minus 2 times x plus 1. Okay. Now hopefully you can see that if we are just in our algebra class, that if we had x minus 2 over x minus 2, we could cancel those out, right? They would go to 1 because these are factors, so this over this would be 1, and this would go away, wouldn't it? So the x plus 2 would go away. But what I would say here is that at x plus 2 equals 0, otherwise known as x equals negative 2, we have a hole in the function. We have a hole in the function, and if it's a hole, it's called a removable discontinuity. All right, this is really important. However, a removable discontinuity, a hole, of course, is a discontinuity, but it's a specific type of discontinuity. The remaining thing that we have, this is our simplified f of x. This x plus 3 with the x plus 1 over it, they're not factors of each other, and therefore this cannot come out. So then what you'd have to do is you bring this piece out, and you say, okay, when does x plus 3 equal 0? Well, x plus 3 equals 0, of course, at x is equal to negative 3. There is our vertical asymptote. There is our vertical asymptote. So you have to be really careful on the exams. Your professor or the AP may ask you, does this function have discontinuity? If so, are they removable or non-removable? Well, in this case, this function has two discontinuities. It has a hole. Remember, holes are removable just through algebra, but you would normally notate that you remove that hole, or you would just say the function has a hole at x is equal to negative 2. But here, this x plus 3 at the bottom is not removable, and therefore we have to account for when is x plus 3 equal to 0, because when x plus 3 is equal to 0, the whole function becomes undefined. So I hope this is helpful. I want you to remember this, and I'm not trying to confuse you, but holes always discontinuity. Discontinuity. However, not all discontinuities are holes. It's a really important distinction because for you to be asked if there's a discontinuity, your professor or the AP may require that you be able to discriminate between what kind of discontinuity you have. So those are the two types. There's also something called a jump discontinuity, which we'll talk about at a later date, but these are the ones I wanted to talk about now. So thanks for watching. Any questions or comments, let me know. And if you haven't subscribed, please do. Thanks.